Hello! Welcome back to Pwime Numbewednesdays and to my new tapestry. I today am excited to answer two of your questions that have come up repeatedly. The first one being, how do we know that there are infinitely many primes? We're trying to prove whether there are infinitely many Mersenne primes, but what about all primes? How do we know that? Well, this proof is a proof by contradiction, and many of you will know this proof already, and so to make it new, I am going to sing it for you. And yes, I did come up with this song tonight. So, enjoy! Let us suppose that there are finitely many primes. Then there is a biggest prime of all, and we'll call it P. Capital P, capital P. Here it is on the number line. Smaller numbers this way, bigger numbers this way. There are no more primes bigger. This is the biggest prime. Let us multiply all the primes all together with each other. 2 times 3 times 5 times 7 times 11 times 13 times 17 times 19 and so forth all the way to P. What does this equal? What does this equal? We will call it C. Here it is on the number line. It is bigger than P. And now we will look at C plus 1. Is 2 a factor of C plus 1? Is 2 a factor of C plus 1? No. 2 is a factor of C, and so 2 cannot be a factor of C plus 1. Is 3 a factor of C plus 1? Is 3 a factor of C plus 1? No. 3 is a factor of C, and so 3 cannot be a factor of C plus 1. Are any of these factors of C plus 1? Are any of these factors of C plus 1? No. All those primes are factors of C, and so those primes cannot be factors of C plus 1. What does this mean? C plus 1 is prime. Capital P was supposed to be the biggest prime of all, but C plus 1 is bigger than P, and it must be prime. Impossible, 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 impossible. Ta-da! Ta-da! That was fun. One more thought about that proof. When I first heard that proof by contradiction, I thought, what a great way to find new primes. You just multiply together consecutive primes and add 1 and you get another prime. Well, that doesn't hold up because, for example, 13 is not the biggest prime. There are other primes bigger than 13 that can divide 2 times 3 times 5 times 7 times 11 times 13, and they do. So just to round out that thought, and I'll finish with the second question that you guys had for me, which was actually about my journal. about this spiral representation. A few of you said, that looks like the Fibonacci spiral. And I thought, that's a great observation. I myself did not make that connection. They are very similar in layout. Now, I've drawn them to look completely different from each other because the way that they represent what they're trying to show, they do it in different ways. So with 2 to the power of n, what I'm counting is the unit squares. Starts out with 1, then becomes 2, then becomes 4, then becomes 8, and so forth. With the Fibonacci spiral, what you're doing is you're looking at the side lengths of the squares. So you're looking at, this is a 1 by 1 square, so you're thinking 1. Same here, and then a 2 by 2 square, 3 by 3, 5 by 5, 8 by 8, 13 by 13. So you're thinking about the side lengths as opposed to thinking about the units. Also, the differences between these two, the Fibonacci spiral is becoming closer and closer proportionally to a specific rectangle, the golden rectangle. 2 to the power of n, the way I've represented it here, flip-flops back and forth between being a square and then being a 1 by 2. Then it becomes a square again, and then a 1 by 2. Then a square again, then a 1 by 2, and then a square again. So it's not approaching anything. I just find it so interesting that, yeah, these two do have that relationship of using a lot of squares and fitting neatly together, starting out with those 2 unit squares in the middle. I haven't figured out what a relationship between these two might lead to, but if you have other ideas, please let me know. I'd be very interested to hear those thoughts. Again, thank you for pointing that out. I hadn't made this connection myself. I just tried doing things in a spiral just to see what happens because spirals seem to reveal things sometimes. So there you go. Next time, we're going to look at more Mersenne number representations visually, this time in 3 dimensions. So I'm looking forward to that. Have a great week. I will see you next time.